All right, we're live. This won't take very long because all we're doing now is taking our fancy new identities that we've learned in 6.2 and adding them to, this should actually say, you know what this should say? This should say T5. Want to fix that? We're back to T5. We're doing algebra with trig. We're solving trig equations. Only now we have a new tool in the toolbox. We can solve these trig equations using our new identities. So, first one, solve for sine 2 theta equals sine theta over the interval 0 to 2 pi. What do I know about sine 2 theta? Go to my formula sheet, and there's only one thing I can do with sine 2 theta. I can make it 2 sine theta cos theta. Now, here is where you must resist temptation. Resist temptation. I sound like a preacher. Resist the temptation. Do not divide both sides of the equation by sine theta. I know you're thinking, well, that would make it super simple. Then I've just got cos left. Yay. You know what the problem with that is? And this popped up last time we were solving equations. It costs you one of the answers. And it's actually wrong. You see, if sine of theta can be 0, and it can, and it is, remember that that's actually the one unbreakable rule of all of math. You can't divide by 0. Dividing both sides of the equation by 0 is wrong. Dividing anything by 0 is wrong. So how do you solve this thing without doing that step of dividing both sides by sine theta? You move everything to one side, and then you use your factoring skills. Factor out sine theta, and now you can see, oh yeah, sine theta is equal to 0 is definitely one of my solutions, right? Because I'm in factored form. This times this is 0, which means that sine of theta is 0, or 2 cos theta minus 1 is 0. Okay, what if sine of theta is 0? Well, sine of theta is 0 when theta is 0, pi, and 2 pi, right? And always check, right? Oh yeah, square bracket, so it includes 2 pi. Square bracket, so it includes 0. The other answer would be when cos theta is equal to 1/2. When does that happen? Cos theta is 1/2 when my reference angle is pi by 3. And then I think to myself, how many times will that reference angle work in this interval? So I might even draw myself a little sketch. Of course, on a test, I'll have a blank unit circle I can draw on, right? So when is that? When is cosine positive in the pi by 3 family? Well, that'll happen here and here, right? So at pi by 3, so my theta here is pi by 3, and then what's this guy? What's that one? Yeah, and another pi by 3, I'd be fully at 2, which is 6 pi by 3, so that's 5 pi by 3. I do have some guys who sadly, they'll make the right diagram, they'll pick the right thing, and then they'll count wrong. So make sure you're counting your way around the unit circle properly. So there we go. There's my 2 equations for that one, or my 2 sets of solutions for that one. All right, example 2. Determine the non-permissible values of the following. All right, so tangent is sine over cos, right? And of course, so that means you can't divide by 0, so cosine of theta, so the non-permissible value, is cosine of theta is equal to 0, which means that the non-permissible value is theta is pi by 2, and oh, look at that, there's the curved bracket, but you don't get that far, that's okay. So, didn't I say 2 and then I wrote a 3? Yeesh. And what's the other one? Cosine is 0 at pi by 2 and 3 pi by 2, right? Right? Here and here, cosine 0, right? Okay. So there we go. Now, you know what? I did have this question the other day from somebody in ESB. Should I write this as an equals or a not equals? Because you're trying to say what the non-permissible values are. And the answer is I don't care. As long as I can clearly see in your work that, oh, the non-permissible values happen when theta is equal to these, then I know that you were communicating properly. But if you don't say non-permissible value, it's perfectly fine alternately to write it like this and actually solve it as in equals. Your thoughts? What is it with me and the number 3 today? There we go. There we go. Thank you very much for noticing that. So if you write it this way and you don't say non-permissible value, you just say, hey, this is what theta definitely cannot equal. Both of those notations are fine. But if you do use the equals notation like I did, make sure you're writing somewhere, hey, these are the non-permissible values. Okay? All right, now let's solve the equation over the above interval. So we're going to solve it. So I'm going to go back to sine theta over cos theta. I won't even bother going back to the tan. Is equal to 2 sine theta. Now, what can I do with this? Well, how about I move everything to one side of the equation? And have 0 on the other. So that opens up my ability to use my factoring skills, right? Because with my factoring skills, I can now solve, because 0 is on the other side. If you're going to solve an equation using factoring, 0 has to be on the other side. So I'm going to now factor out sine theta. And that gives me 1 over cos theta minus 2 equals 0. So I have two, I'm kind of running out of room. I have two sets of solutions. Sine theta is 0 is one set of solutions. And 1 over cos theta minus 2 equals 0 is the other set of solutions. Okay, so let me do this one first. Sine theta equals 0. So that means that theta is equal to, now careful, look at the interval. See this interval? Dum, dum, dum. 2 pi doesn't count. Why doesn't 2 pi count? Because of that curved bracket that says 2 pi is not part of the interval. You can approach 2 pi, but you can't equal it. So that means that it's not one of the solutions. The solution is just 0 and pi, not 2 pi. So that takes care of this guy. The other guy happens, okay, I'm going to have to do a little more algebra for the other guy. 1 over cosine of theta minus 2 is equal to 0. So this is one set of answers. This is going to get me another set of answers. I'll move 2 to the other side. And then I'll reciprocal both sides of the equation. And hey, we just did those. Where is the cosine of theta 1/2? At pi by 3 and 5 pi by 3. Then we do a quick check. Are any of these answers non-permissible? Nope, we're good. The answers we couldn't have had were pi by 2, 3 pi by 2. And that's none of these answers. So these are good. What about 0? Oh, right. Sorry. Hang on. I put a premature check mark on that. Theta can't be 0. So therefore, I should make a final answer. Sorry, I'm out of room. Final answer. Theta is pi by 3, and 5 pi by 3. We had to throw out the 0. The 0 is non-permissible. Thank you for noticing that. All right. More equation solving. Check out this one. Ah! Tan x, cos x, sin x, cotangent x, cosecant x. It's like somebody just mashed a keyboard until all this stuff kind of spilled out. All right, what are we doing with all this mess? Well, again, kind of like when I hit identities and I'm doing proofs, probably will be helpful if I just put everything in terms of sine and cosine and see if I can simplify it from there. So tangent is sine over cos times cosine times sine, and cotangent is cos over sine, and cosecant is, I wrote it when I was trying to change it. Cosecant is 1 over sine, and all that minus 1 is equal to 0. Well, okay. What happens when you divide something by itself? You get 1. Now, careful though, there is one number in the universe where that wouldn't be true for. 0 divided by itself is not 1. So that is where I have to think about, first of all, my non-permissible values. So my non-permissible values are, of course, cosine of x equals 0 and sine of x equals 0. I'm going to just leave them. I won't bother solving those for now. I'm just going to leave them off to the side. As long as those are not permissible, I can do some canceling. Cosine divided by cosine of any angle other than 0 is 1. Sine of x divided by sine of x is 1. So sine of x divided by sine of x is 1. It looks like this thing just simplifies all the way down to the cosine of x minus 1 equals 0. So the cosine of x is equal to 1. And x would equal then between 0 and 2 pi. Well, cosine of x is 1 at 0 and 2 pi. So normally I'd say my answer is 0 and 2 pi, but 2 pi does not count. So the only answer here is cosine of x is 1 when x is 0. Unfortunately, cosine of x equals 1. No, that's okay. X, that works. Non-permissible value, that works. So that is my answer. Okay, cosine, if this had been cosine of x equals 1, I'd be worried. Sine of x equals 0 is not a problem. Okay. Next, cos 2x plus 1 equals cos x. All right, go to your formula sheet. Remember, there are 3 choices for what cos 2x is? 3 choices of identities I could swap out. Which one do you want? Which one makes the most sense? How about the one that's involving cosine only, so that I don't have a question that mixes cosine and sine? So that's what I'm going to do. I'm going to pick the one that is, use the one only in terms of cosine. So I'm going to replace cos 2x with 2 cos squared x minus 1. So I have replaced this thing with that thing. And my identity sheet says that I can't. Somebody usually asks me when I'm doing this, do I have to like indicate somehow on my work that I replaced a piece of the equation with an identity? No, that's my job. If you write it exactly the way I'm writing it, I have to say, oh, they replaced an identity there. And if I can't follow that, I shouldn't be marking this stuff. So nope, this is perfectly explained work right here. You don't even have to highlight it like I did. I'm just explaining where I got this from. Okay? The minus 1 and plus 1, of course, cancel. And a good idea, again, is to not think I want to divide both sides by cos. No. Go to your factoring skills. That's the way to do this. Now I'm going to factor out cosine of x, leaving me 2 cosine of x minus 1. And my solutions are going to be cosine of x equals 0 and 2 cosine of x minus 1 equals 0. So that's cosine of x is a half. And we've seen these answers already. Do we have a domain here that we have to worry about? From 0 to 2 pi, not including 2 pi. That's for both questions. So x is equal to, let's see, when is cosine 0? At pi by 2 and 3 pi by 2, right? That's when cosine 0. And when is cosine a half? Cosine is a half at, when is cosine a half? Cosine's a half at pi by 6. Am I right about that? Or is it pi by 3? It's pi by 3. Yes, sine is a half at pi by 6. Rats. Pi by 3. And when else? 5 pi by 3. Yeah, we just did this one. Why am I thinking about it? Oh, most books then will actually put it all into one solution. I'm actually happy if you underline them both. But if you're looking at a textbook solution or an answer key, they're going to put them all down, and they usually go smallest to biggest, just so you have one more thing to think about. Pi by 3, pi by 2, 3 pi by 2, 5 pi by 3. That's the 4 answers that would make that equation true. And if you ever want to check, if you ever want to actually verify an answer, you could plug them in and check them. I don't know that on a test I'd want to spend time verifying 4 different numbers. But if you were ever stumped, if you ever disagreed with an answer key, you can check. Run that through your calculator even. It should work. Okay, let's get into heavier algebra. Dun, dun, dun. All right, what am I going to do with that? Once again, it's kind of hard to solve an equation that has cosines and sines in it, so I kind of want one or the other. And I remember that my favorite identity, the first one, the one that makes Pythagoras proud because it's really kind of his identity if you really want to think about it. X squared, or a squared plus b squared equals c squared, x squared plus y squared equals 1 squared, sine squared plus cos squared equals 1 is my identity. And I can rearrange that so that cosine is 1 minus sine. Sorry, with squareds on them. Cosine squared is 1 minus sine squared. That's what I'll replace this with. So I'm going to replace that cos squared with, and do this in a bracket so that you don't lose track of all the negatives, 1 minus sine squared. And then the question usually comes up, how did you know to do that? What else am I going to do with it? Experience is how I knew how to do that. Logic, reasoning. I have tools in my toolbox that I can use. This is the one that's going to get me an answer. Question? Oh, I guess I could have done that. Yeah, okay. That's what I'm going to get anyway. Yeah, good point. You're doing one less step of thinking than I am. The question, if you didn't hear it at home, was why not just look at this and replace it with sine squared x? Yeah, sure. It works. We both ended up at the same place. Okay, now what? It's a quadratic. How do you solve quadratics? Move everything to one side. Notice that's kind of the way we solve most of these because our factoring skills tend to come up more than any other type of algebra skills. And factoring kind of needs to have 0 on the other side to work. And now I think about this as x squared minus 3x plus 2, which is sine x minus 2, sine x minus 1. Okay, if there's people wondering, how did you go from this step to this step? Think back to grade 10, when you had x squared minus 3x plus 2, and you factor that into x minus 2, x minus 1. Right? That's what I'm doing there. Okay, so sine of x is equal to 2, and sine of x is equal to 1. What do you know about sine of x equals 2? Sine of x can't equal 2. No solution. That saves some time. Sine of x equals 1. When does that happen? At pi by 2, right? All right. Next. Once again, usually our identity strategy is to switch everything to sines and cosines. So what's cosecant again? Cosecant's 1 over sine. All right, you got to know that. Sorry. That we won't give you on a formula sheet. Okay, now what? What do you want to do with that? Well, again, think of the tools you have in your algebra toolbox. You can factor. 2 sine x doesn't, sine 2x as an identity I can replace. 2 sine x doesn't tell me much of anything. No, I think I'm going to multiply both sides of the equation by the common denominator so that I don't have a denominator anymore. So I'm going to multiply both sides of the equation by sine x. So that now becomes sine squared x over here, 7 sine x. And of course, when you times this thing by sine of x, it cancels the denominator, and I get minus 3. Again, how did you know to do that? Experience, logic, reasoning. I have this tool, how does the carpenter know which tool to grab from the toolbox? And you use your logic, your thinking skills, and your prior knowledge, your background knowledge, right? It all kind of comes together to tell you what to do. And there we go. And again, I'm thinking with my grade 10 factoring skills now. Right? Think, again, I'll write it out and think, what is 2a squared minus 7a plus 3? Gonna going to factor to? Well, I know that 2a squared can only be made by going 2a times a. But then from there, 3 can break down into 3 and 1. And if two things times to make a positive, they're either both negative or both positive. And they wouldn't add up to a negative unless there are negatives involved. So I know they're both negative. And if I put the 3 here and the 1 there, when I FOIL that back out, I'll get the 7th. So there's my factoring. And then there's usually that person sitting there going, oh man, I never did get the hang of factoring. So how did you survive grade 11? What did you do? Did you lean on the quadratic formula? Because you could do that here too. And you never know, we might actually give you one that doesn't factor, in which case you got no choice but to use the quadratic formula. So there we go. Sine of x equals 1/2. Sine of x equals 3. You have no solution because you can't have a sine value bigger than 1. But that one, of course, would be, let's see, so my reference angle for 1/2 is pi by 6. And what's my range again here, or my domain here? I have to go all the way up to 2 pi. So my final answer for x is pi by 6, and then sine is positive here and here. So the other answer I want is 5 pi by 6. Okay, these examples are by no means meant to be comprehensive. We could do other things to you, like give you ones that don't factor, and you have to break out the quadratic formula. We could also give you ones that aren't on the unit circle, and you have to do it the way we did it back in T5, break out a calculator. And there's some in the homework, there's at least 1 or 2 in the homework where it's like that. It'll say, give the approximate value, which means, aha, that one's going to work out to be not on the unit circle, and I have to use my calculator again. So yep, T5 is kind of back, but now we also have trig identities that we can mix in with it. So there you go. That's the 6.4 lesson. Let me just stop that. We still have a few minutes left here in class. Anybody got any proofs that they're stuck on?